Soften your senses. Ways to become a better speaker, listener, and follower. This episode brought to you by Lennox International, providing perfect air through innovative and sustainable climate control solutions. Learn more at lennox.com. All right, everyone, welcome to Did You Know the ESCO HVAC podcast. So we're hanging out here at the 2024 National HVACR Education Conference, and I'm spending time with Tom Cates from Lennox International. How you doing, Tom?
Good.
So are you enjoying yourself?
This is a great show. My second time here, and it's been really informative.
Oh my gosh, we've had so much fun and learning about new technologies and innovations. And one of the things that we have to focus on is the capabilities and limitations of equipment when in considerations to design and selection, making sure we're doing things right and we're doing a better job of what we should have always been doing, right?
Absolutely. Yeah, equipment selection is critical, especially as we move into this heat pump age.
Oh my God.
That's rampant across North America.
Inverter-driven stuff, particularly speed motor, ACMs. Some things can be a little bit more forgiving, but they shouldn't be.
Yeah.
Right?
Well, gas furnaces, right? If you put a big enough one in, it would heat your house, right?
Absolutely.
And maybe not necessarily overly efficiently, but the purpose of going to heat pumps is efficiency. That's what all this is all about.
Yeah.
And if we're oversized or undersized, and the consequences of either one of those is much greater than what it is with a fossil fuel piece of equipment, for sure.
Yeah, absolutely. Yeah. And so it's going to be really critical. So let's walk through some proper practices and best practices in doing that.
So first off, we got to know what the load of the house is, right? Or the
Absolutely.
building, whatever it is. And that's critical. And, depending on where I go across North America, some people are doing it on a regular basis. Some people are not. So I'm from Toronto, Canada, and in Ontario, it's mandatory in every new house construction that a load calculation, duct design, and ventilation report is completed for every single new house being constructed. So it's created a whole design industry,
a movement.
And so the other provinces of Canada are kind of a little bit slower in picking this up now. Specific cities have started to adopt it. Vancouver and British Columbia, Regina and Saskatoon in Saskatchewan. And Edmonton and Calgary and in Alberta have also kind of adopted at least load calculations. It's picking up at the conference here. Ed was talking about, for ACA was talking about, the importance of manual J calculations, which is what you guys use here in the US. Yeah. In Canada, we use a CSA standard called F280-12. And there's been different versions of that standard over the years. The newest one, the latest one, is a little bit more complicated than the older versions, where you actually have to use software really to be able to do it properly. Proper calculation. Yeah.
That's cool though to talk about that, because a lot of people are kind of hesitant to change, hesitant to bring in technology in, but really it's just making the work that needs to be done, has to be done, more efficient.
Yeah,
right?
That's right. Yeah, and the idea behind the software is you got to know what input, the right data to input in to get the right output out, right? And that's where folks struggle is they can't always identify what the right data to be put in is. But once you understand that through either ACA classes or HRI, which is what we use in Canada to teach F280-12, once you understand that, the process can be quite streamlined and simple. Yeah. And it doesn't have to be complicated. It certainly could be depending on how much detail you want, but for the folks that aren't doing it all, let's just do something as opposed to doing nothing. And we're moving in the right direction. That's right. That's my opinion anyway.
We've seen technology make that so much faster than it has in the past. We're seeing applications that can use things like LiDAR for scanning rooms. We have so many new tools for making that a lot easier. So it's really interesting to be able to talk about the differences between what's happening here in the United States and what's happening in Canada. And so you're already progressing into requirements for load calculations. And how is that as a manufacturer? Do you see a difference in, say, even like warranty returns and technical support calls? You see less in Canada than you would in the United States because we're doing things better?
I would tend to suggest so. That's
I would
not
think
my
so.
department within Lennox, so I can't actually comment too much on it.
But in generalization,
absolutely, I would assume that's the case. So if we know what the load of the house is, we can better select our equipment.
Yes.
And then if you've got the right equipment in, then the longevity of that equipment is gonna stand up, right? And so one feeds into the other for sure, 100%.
Yeah, and a lot of people don't think about that perspective. They go, "Oh, I got to do all this extra work." Well, you're doing the extra work so that you do things right.
Yeah, that's right. And I said I had one of my students here that we went out to dinner for on Sunday night, and he was asking, I'm not getting paid to do these load calculations, so they're kind of tough to do. And I said, well, just include it as part of your package. You don't have to do it up front, but if the customer does decide to go with you and your company, then it's what you're going to provide to them as an additional service. And it'll actually separate you from your competition
in a big way.
In a big way. So in theory, you can actually get paid for it because you can charge a little bit more because you're documenting the stuff that the homeowner needs available to them, and you just include it as part of your package price, and they don't know any different, and you get the benefit of being one level above your competition and doing it right.
And that's it. And so many people are looking at the different avenues to incorporate that into your current structure and your current design, and all of them say the same thing. And I get it. If you approach that homeowner and you start talking about actual hard factual data, derived from a load calculation, and you ask them to make sure that their other estimates have included that, and then they go, "Oh no," almost all of them say, "Oh no, they didn't do anything like that." And you have the opportunity to truly show your professionalism.
Absolutely, 100%. 100%. Yeah. And then once you've got the load calc of the building, then you can really start to narrow down what the equipment is going to be, right? Especially when you're talking about heat pumps. So, if it's gas furnace, and you get a 55,000 B2 load, you're likely putting in a 60,000 B2 furnace that goes along with that. Sure. But there's much smaller increments of capacity when we talk about heat pumps, right?
Goodness,
we're into 6,000 B2s of capacity increments. So you can really start to narrow it down. And, the capital cost of heat pumps are more expensive than a gas furnace as well. So when you start to just make a guess, you could be guessing high, and cause maybe some comfort issues and efficiency issues, and capital cost increases. If you guess low, you don't meet those comfort expectations that the homeowner has assumed they've been paying for, and the efficiency that goes along with it, right? So, why are we putting these heat pumps in? Certainly, the green energy transformation that's going on is part of it.
Yes.
But at the end of the day, homeowners are looking to save dollars and cents in most applications, right? And so having that proper size feeds into the equipment selection process and allows you to make some choices around, especially with heat pumps, right? Because we've got small increments, and in CSA F28012, when we're talking about heat pump selection, we generally suggest that it's based around the cooling needs of those buildings. Yeah. It depends on what area of the country you're in.
Sure.
But we've got a range in CSA F280 that says you can size your equipment between 80% of the calculated load of the building and as high as 125% of the calculated load of the building. That could be three different capacities of heat pumps, right? So now you've got documentation to say, well, your house actually needs a 3-ton or a 36,000 BTU, where your competition might come in and say, well, you can get away with a 2.5 ton, or somebody else comes along and goes to the higher end of the scale and says, well, you need a 3.5 ton. Now you're not, and we see this all the time. I hear from customers, well, I got 3 different capacities from 3 different contractors.
Why is it?
Which one's the right one? Well, the right one is the one that goes along with the heat loss that they provided for that particular building.
That's exactly right.
Yeah.
An interesting thing when we're talking about heat pumps is and we're struggling here in the U.S. for adoption of heat pumps because so many contractors have gotten stigmatized by the 1960s and 70s rollout of heat pumps in the U.S. that weren't always successful. It all comes down to proper selection and installation and commissioning. It always does. And so, we're having a little bit of a struggle to encourage people and convince people that they absolutely work in the upper part of the United States. And here we're talking about heat pumps in Canada, right?
Yeah.
Okay.
Yeah.
So we know that in the United States in 2022, the sale of heat pumps surpassed gas furnaces, right? So in Canada, are you seeing a significant increase in the amount of heat pump installation?
Absolutely, 100%. So the Maritimes, kind of east of Ontario.
Yeah.
Quebec is doesn't really have fossil fuel as an option. So they're almost all electrifications. They've got really cheap hydroelectricity generation.
That makes sense.
And so it's nice and green. And straight electric systems have been promoted in Quebec for a long, long time. And just switching those straight electric resistance heating to heat pump systems can help improve the energy grid, demand, how we're delivering our electricity. And then when you move further east into New Brunswick, Nova Scotia, and Prince Edward Island, they really don't have natural gas at all. And so they were using a lot of oil-based systems. And the federal government of Canada has been incentivizing all of Canada, but the Maritimes have really taken advantage of it because they don't have fossil fuels. So now they're really comparing electrical heat pumps to electrical resistance. And now you really do see your 3 and 4 a coefficient of performance, improvement. And so there's actual dollars and cents that they can see in their bank account being saved every switch from that straight electricity to a heat pump system.
And so when you're doing that proper selection, that proper calculation, proper selection, and then adding incentives on top of it, and now we've got a consumer that's saving money, still living comfortably, and contributing to the I don't always like to call it the decarbonization. I like to look at it as just the reduction of our carbon footprint in general.
And any movement forward to help with that, and it can't hurt.
No, absolutely can't. I mean, it's the right thing no matter how you look at it.
That's right. We can all have disagreement as to whether it's, what is being caused by why. But at the end of the day, if we're all making one step in front of the other, at some point, we'll get to where we want to go.
We'll make the progress happen.
Yeah, that's right.
Yeah,
100%.
Do it all better together. I love hearing that because we have had that struggle here in the U.S. And to know that, Canada is embracing that and it's being successful, that takes every contractor in America that was, curious about whether it actually be successful in the United States and go, oh my gosh, if it's successful north of us, it has to be successful here.
And Vancouver, the city of Vancouver has essentially eliminated fossil fuel equipment as an option.
Absolutely.
It's been removed. So, when I traveled to BC, Vancouver specifically, I went into the Lennox dealership and, the guy behind the counter said, no, I don't even have a gas furnace in stock. That's all they're selling is a heat pump based application, which was new to me. And this was as recent as 2 years ago.
Oh my gosh, that's
and that's a new phase that not every province has adopted, but because the city has mandated energy efficiency requirements, that's been the end result.
That's the drive.
Is fossil fuels just no longer accepted in that particular city?
Yeah, absolutely. When we look at here in the United States, we're starting to see areas. New York is already starting to dive into that, both the city and now looking at the state. We have a variety of different local jurisdictions as well as counties and states that are moving for that adoption. So even if we don't make this happen quickly as a country, we're going to see local jurisdictions moving that direction.
Yeah, they will. Yeah, absolutely they will.
Yeah. But we just have to be aware of what that looks like. And then also to look at successful transitions as well, like we're seeing in Canada and going, this absolutely is realistic.
Yeah. And they're not, when I get up into the northern parts of Alberta and Saskatchewan, heat pumps alone are probably not the best choice.
No, you gotta have multiple fuels.
But a dual fuel option really becomes a viable option for those locations. And when you look at load calculations, you can we base those essentially around the worst days, coldest days of the year in winter and the warmest days in summer. But you can model that when for the other days that aren't the coldest or aren't the hottest. And you can really start to see where the heat pump can be beneficial in both reducing your carbon footprint as well as saving in dollars and cents. And so that leads into a balance point as to where it makes economically sense to run your heat pump for a certain period of the winter season and then switch over to your gas furnace for another portion of the winter season. Edmonton, Alberta, I think has a minus 40 degrees C design temperature. It doesn't hit that very often, but they might get 14 days. Yeah, that's right. And so, an air source heat pump at minus 40, even with a cold climate, still isn't going to do what we're going to need to, right? And Alberta, unfortunately, has really expensive electricity costs, and so for them to go to an electric backup, it just doesn't make sense. And unfortunately for the federal government, they're getting a lot of pushback from the West Coast with this green incentive that the federal government is pushing in Canada.
Yeah. We've talked about this in a variety of different applications, and I'm kind of the same way. You can look at it in any path, any direction you want. What it really comes down to is providing a solution that the homeowner is wanting and can afford and really fits the bill. And so for some people, it's straight heat pump. For some people, it's heat pump with electric backup. Some it's heat pump with gas.
Yeah, that's right.
So there's multiple ways to achieve the desire, and the total desire is just getting that most efficient system that we can that can serve the purpose of the homeowner. And we have those solutions. We just have to be willing to look at them.
That's right. Yeah. We have to be willing. Yeah, and sometimes that's a hurdle that we sometimes have a hard time jumping over.
Oh my gosh. Yeah. All right, Tom, thank you so much for joining us. I really appreciate having you here, and look forward to seeing you.
Excellent. Well, I really appreciate you giving me the opportunity to speak on behalf of Lennox and the entire industry. I'm going to come back to this show as much as I possibly can. And I've got a new colleague that I brought this year, and I'm going to bring a couple more next year.
There we go. It's great having you here,
all right,
friend.
Thanks a lot.
Thank you.